Next is example 2. This frame as shown in figure used to support hoist for transferring loads where the dolly weight is 3 kN and the beam mass is 24 kg per meter. We need to find the support reaction at A and B, then find the maximum moment at D. The dolly size negligible and can travel the entire length of the beam. So if we can see in real life, this how it look like, where this is the beam and the load from here going to move along the way of this beam. So back to our question. So we can simplify our beam at support A and B and the length throughout C to B with the staff weight is 24 kg per meter and the dolly is 3 kN. Now we need to identify influence line for RAA, reaction at A, influence line for RB at reaction B, and influence line for MD at point D here. So for influence line RA, we need to release support at A, then we introduce a force at point A. Then we get 1 here, then this is the deflated shape for that case. So this is the influence line. Next, we need to draw influence line for RB. So we need to release at support at B, then apply the force. So 1 unit here. So hold at A, so this is the influence line for RB. Then we need to draw influence line for MD at point D. We introduce internal hinge. Then we allow rotation at point D. Please remember, still hold here at A and B. So our ruler going to be deflected like this. So this is our influence line for MD. Now we need to determine those important value. We go for influence line RA. We know value 1 is here, so we need to find value here. So to do that, we can use interpolation. At value 1, the total length here is 3 meter and the total length until the end is 3 plus 1 is 4, and we don't know that value, so we name as x, so we can find what is x. So x is 1.33, so here is 1.33. Next, we do for influence line RB. We know 1.0 is here for the total length of 3 meter, but we don't know yet value here with the length of 1 meter. So 1 to 3, we don't know this value yet, so we name as y, and the distance for that is 1. So we get y is 0.33 because that on negative side, so negative 0.333. Then for influence line MD, we know the formula for the top at D is AB divided by L. So 1.5 times 1.5 divided by total length is 3. So value for here is 0.75. So use the interpolation. Here is 0.75 for the distance of 1.5. So distance here is 1. We don't know the value yet, so we name as Z. So we can solve this. We get Z is 0.5. Since that's on negative side, so negative 0.5. So we identify all the important value. Then we can find what is the maximum reaction at A when dolly at point C. So that is RA max. Refer to our influence line for RA. So 3000 the dolly weight times by 1.33 because dolly at C. Then we need to plus area of this triangle. So area for this triangle is half times by 4 total length times by 1.3. And don't forget, the safe weight for the beam is 24 kg, convert to Newton times by 9.81. Solve this and we get our RA max is 4.6 kN. Next, we need to determine maximum reaction at B. So, influence line RB. So for that one, we have 3000 times by 1 because the dolly can move. Then we have safe weight 24 times 9.81. So we have this area, this triangle. So that is the area for that, half times 3 times by 1. Then we need to plus another area here, small area here, small triangle. So plus 24 kg times 9.81. Area for the orange one here is half times by 1 meter times by negative 0.333. Solve this and we find our RB max is 3.31 kN. Next, we need to determine maximum moment at D. So here is influence line for MD. We have two area. We have dolly 3000 times 0.75 plus area of this triangle. So 24 times 9.81. Area for that is half time. The length for that is 3 meter, 1.5 plus 1.5. The height for that is 0.75. Then plus area for this small triangle. So 34 times 9.81 times area of that one is half times length times negative 0.5. Solve that and we get our moment is 2.456 kN meter.